still works, as we can see there. And it's pushing more like 200 milliwatts. However, this veroboard implementation of it doesn't anymore. So what am I going to do with it? Pretty much that. Greetings, the Astro 30 here yet again, and welcome back to AEL. Now, if you're new to this channel, please consider going down below and subscribing if you haven't done so already. So, what actually happened to this little amplifier? Well, I ended up with a shorted transistor, this one here. It was shorted between emitter and base. So that's why it was initially not working. The output must have shorted or something like that. And so I replaced the transistor, and then all I got was garbled sound out of it. It just was not working correctly. So other than that, I don't know what the heck's going on with this amplifier. Maybe this transistor's got some internal damage as well, but it still functions on test, but doesn't actually function electrically. Who knows? So I've gone and done something which I should have done back in 2013. I will put a link in the description to this original build. I've got some PCBs made for it. And as I said, I should have done this a couple of years ago, but I didn't. So that's all that's in the box. It's just some little PCBs in a plastic baggie, and then got wrapped in that foam stuff, whatever it is. So I'll just get this out of the bag. I think I ordered 10 of these actually, not 5, yeah, 10. So I'll get one out and we'll have a little look. And there it is there. 100 milliwatt utility amplifier. And the quality of this is pretty good. I'm quite pleased with how it's turned out, as per usual. There's, you know, not much to complain about here. Now, I didn't put my little logo on it because there was just no room, not even on the back. So the little anime girl, the Asuna, is not on there, but that's really neither here nor there. So as we saw in the intro, I've rebuilt the circuit on breadboard, tested it, and it works fine. Whereas, of course, this version doesn't anymore. It's just distorted output. So what I'm going to do is I'm going to basically take the components off of this piece of veroboard. And the other issue is, as soon as you start soldering to this stuff over and over again, the copper tracks just start to delaminate and fall off. So they don't make veroboard like they used to back in the 80s. It's pretty shit now. So I'm going to take off the capacitors. I'm not going to reuse the transistors. I'll reuse the IC socket and just use new resistors. So what I'm going to do next is start building this thing, and I'll build it in time lapse, and when it's finished we can test it and see how well it works. But before I do that, I don't know if I did in the original video properly. I'm going to go through it and re-explain the schematic, because I don't think I did that properly in the first place. So anyway, let's have a look at the schematic and then we'll start building. Okay, and here's a look at the schematic. It's pretty simple, so I'm not going to go into too much depth. The heart of it is a NE5532 dual op amp. You could use a TL072 or any dual op amp you want. We've got pin 3 here biased at half the supply voltage with these two resistors which form a resistive divider. This makes the op amp work, so the input signal comes through here, through this 10k impedance set resistor, 470 picofarad RF blocking capacitor, and a 10k volume pot. This goes through a 100 nanofarad capacitor into pin 3. Now this will mean that you won't get full bass response out of this. It'll cut off at around probably 400 Hertz. So the first stage is a non-inverting amplifier, and its gain is set to 101 with this feedback resistor and gain resistor respectively. It's designed to amplify weak signals like a radio front end, for instance, which is only about 50 millivolts or so. If you want to amplify a slightly stronger signal like 500 millivolts, then you can probably halve this down to like 47k, so give you a gain of 48. That then DC biases the next stage, which is the other half of the NE5532 at pin 5 here. This is configured as a voltage follower, which is driving a MPN and PNP pair of transistors respectively, which are emitter followers. So the feedback is also taken from the emitters and fed back into the inverting pin 6. So this makes the whole entire thing a voltage follower producing no gain, but these transistors will be allowing more current to flow into the speaker than it would be if you were just to drive it from the op amp directly. And this is configured in Class B configuration. That goes through a 100 microfarad capacitor out to the speaker through a Zobel network via this 10 ohm resistor and this 100 nanofarad capacitor. Up here on the 9 volt rail, we've got a 470 microfarad smoothing capacitor and a 100 nanofarad capacitor just to deal with any high frequency noise. This circuit can run happily on 12 volts or even 15 volts. I wouldn't on the PCB because the capacitors are only rated for 16 volts. So I'd stay no higher than 12. I also just noticed down here that this capacitor, 1 microfarad, has no designator for it. I'm going to have to correct that before I upload the article to PCBWay as a shared project, just to make sure that the bill of material is referring to a component that has a designator. Anyway, that's a look at the schematic. It's not that overly complicated. You can drive a 4 ohm load on this quite happily, and in its current state at 12 volts, it will produce 200 milliwatts into 8 ohms and 300 milliwatts into 4 ohms, respectively. Anyway, let's get building. Right, so there it is, all assembled there. It only took about 13 minutes, 15 minutes, something like that. Wasn't that long. I haven't put connectors in. I'll just use fly wires for the test. So I'll pop the NE5532 in to the IC socket to complete this build. And now we'll hook up some fly wires, as I said, and test whether this thing actually works. I'm just going to be very, very careful of this J2 connector here, because the positive speaker lead is close to the ground on this input lead, and I don't want the clip leads touching each other if I can avoid it. In fact, the ground for the input I might take off of the speaker's ground, just to be safe. And DC's all the way over here, so alright, let me use some of these offcuts of resistor pigtails and stuff as my fly wires, and I'll solder them in the board, hook it up with some test equipment, and we'll see if this thing works. Bonza. Okay, the little circuit's connected up. I've got the scope going directly to the output. I'm not putting it on a dummy load or anything at this point in time, but we do have a nice sine wave output, saying about 1.83 volt RMS out, but we can ignore that because the circuit isn't loaded. I could easily load the circuit by just applying the speaker across the output. And It does drop a little bit, but not much, but I'm putting a little bit too much volume into the circuit. That's better. And it sounds perfectly fine. It's not very loud, but then again, the speaker is just like sitting out in the open too. So we know that the circuit is actually functioning. Isn't that neat? And special at the same time. That's not the drawer that came out of. That goes in that drawer. So I don't think there's really much else I can do to test this thing. Except maybe put it through an actual speaker and see how it performs, I guess. Alright, it's now going into a proper speaker. There's distortion. It does speak reasonably loud, so it's about akin to, you know, the LM386, only it's probably about 200 milliwatts less power. I did find that when I did the initial test in the intro, that I was getting more close to 200 milliwatts into 8 ohms, which is fine. I mean, for a little amplifier like this, that's fine. Yeah, it is pretty loud. So I'm going to say that this was absolutely successful. Yep. And I don't think I really need to do any further testing with this because, well, you're not going to get any, much louder than that 1 kilohertz signal. I mean, it probably sounds fine with music. I could probably hook up my phone to it and go onto the YouTube audio library and just, you know, play a track, so that's what I'm going to do now. sounded alright. So I'm actually quite happy with how that turned out and how it actually sounds. I mean, it's pretty much close to its maximum now, where I was playing it at. So it's not the most powerful thing in the world, it never was meant to be. But the point was, did the circuit still actually work? Yes, it does. There was absolutely no issue with it. It was just something to do with the piece of shit veroboard. This thing that it was on that's failed. Could be the actual copper traces itself have failed, or they've lifted up a certain point between something and making contact where it's not supposed to, or it's making no contact where it is supposed to. So all that other transistor is damaged, as I said, even though it tests fine. But anyway, so I'm going to leave this video here, throw that other thing in the bin after I steal the remaining 2 capacitors that are on and off. And yeah, if you enjoyed this video, please remember to go down below, like, comment, subscribe if you haven't done so already. This will be available as a shared project on PCBWay if you so wish to build this with a PCB. And the link will be in the description for that. So, as always, it's the Astro 30 saying, see ya, have a great day. I just sounded British then. Here's the Astro 30. Have a great day.